How is it going out there, everybody? Got a short one here for you today on this next installment of Bad Science Communication. Woo! Going off the screen there. Um, this one is one that I've seen doing the rounds recently on Twitter and Facebook. I'm gonna make myself just a little bit smaller there. Um, I'm not really. This is a really short article. I'm not actually sure on the author. You know what? Let me just click here and check. I think we should be able to do that. Joshua Hawkins. I don't know why I didn't do this before. I did take a quick look at the article. It's really short. I didn't actually read it all the way, but I just kind of skimmed it because I knew I was going to read it when I decided that I wanted to do a bad science communication on it. Just fell in love with it. Okay, so I'm not seeing. I mean, it doesn't necessarily mean anything, but I'm not seeing anything indicating some formal training in physics. Again, I don't have any formal training in physics. You know, it's not like the be-all end-all of understanding physics, but when people are like writing articles on it, I actually don't know how popular BGR is as a magazine. This might not even be that popular, so it might not matter. Anyway, the title is Scientists Create Matter from Nothing in Groundbreaking Experiment. Okay, let's see what these scientists did here. We've probably all heard the phrase, you can't make something from nothing. But in reality, the physics of our universe isn't that cut and dry. Interesting. In fact, scientists have spent decades trying to force matter from absolutely nothing. Yeah, so I think this is problematic. I don't know what the notion of absolute nothingness really is. I don't think it's analyzable, in virtue of the fact that I think that definitionally there isn't anything there to be analyzed. I certainly don't think that you could force matter from absolute nothingness. I think that's definitely not a thing that scientists could ever hope to do. And now they've managed to prove that a theory first shared 70 years ago was correct. And we really can create matter out of absolutely nothing. Okay, let's see if that's actually the case here. The universe is made up of several conservation laws. These laws govern energy, charge, momentum, and so on down the list. In the quest to fully understand these laws, scientists have spent decades trying to figure out how to create matter, a feat that is far more complex than it even sounds. We've previously termed matter invisible, but creating it out of nothing is another thing altogether. That's probably a bit of an understatement, if I'm being completely honest. There are many theories on how to create matter from nothing, especially as quantum physicists have tried to better understand the Big Bang and what could have caused it. We know that colliding two particles in empty space can sometimes cause additional particles to emerge. There are even theories that a strong enough electromagnetic field could create matter and antimatter out of nothing itself. And naturally, I already know what the article is referencing. This is not what the Schwinger theory is or Schwinger effect. This is not what the Schwinger effect says. It doesn't state that matter and antimatter can arise out of nothing. But we'll get to that after we finish up the article here. But managing to do any of these things has always seemed impossible. Still, that hasn't stopped scientists from trying, and now that research seems to have paid off. As Big Think reports, in early 2022, a group of researchers created strong enough electric fields in their laboratory to level the unique properties of a material known as graphene. With these fields, the researchers were able to enable the spontaneous creation of particle-antiparticle pairs from nothing at all. That is not what they did. Anyway, this proved that creating matter from nothing is indeed possible, a theory first proposed by Julian Schwinger, one of the founders of quantum field theory. And with that knowledge, we can hopefully better understand how the universe makes something from nothing. So the first problem I have is that this article is way too short, and with some of the terminology that it uses. So it mentions, there are even theories that a strong enough electromagnetic field could create matter and antimatter out of nothing itself. And then they refer to that by referencing Julian Schwinger, but they don't mention the Schwinger effect, and they don't outline what the Schwinger effect is. They don't cite, well, let me see here really quick. Yeah, so this is an article written by Ethan Siegel. This article is a little bit better. The title is clickbaity. Where's the other thing? Because I did read this article fully. then it's this very first part here that I would also question. But outside of that, and then the title, I'm not. This article is not a bad article. Naturally, it's written by Ethan Siegel. He's a very effective science communicator. But this is not a link to the actual study. So they didn't link to the actual study. Even if it is behind a paywall, you should still link to that original study, just as a matter of formality. So that's the first thing I have. The article is too short. It doesn't link to the original study. It doesn't actually outline what the original study did outside of, well, they did some stuff on graphene. This is based on something Julian Schwinger said, and we can better understand stuff now. But they didn't explain what is the Schwinger effect? What is it specifically that the study did? I don't know precisely what the study, well, I don't know what the use of graphene was, but I do know what the Schwinger effect is and how they utilized it. So the Schwinger effect, at least as it was applied in this instance, says that if you take a meson, which is a particle that is comprised of a quark-antiquark pair, and you subject it to a strong enough electric field, well, since the quark and the antiquark are electrically charged and they're going to have opposite electric charges, quark and antiquark, if you subject them to a strong enough electric field, what will happen is they will slowly begin to repel each other. And in this repulsion, what you're doing is you're creating a higher energy state in this system in sort of a really simplistic way. And so what this will do is in an attempt to conserve the energy, the field will produce particle-antiparticle pairs. They're not being created out of nothing. It's a conversion of energy into mass. This is a thing that's been known to happen in physics for over 100 years. This is not creating anything out of nothing. Nothing isn't really a concept in physics that was initially popularized by Lawrence Krauss. Outside of the pop-sci articles like this, physicists don't refer to vacuum fields or quantum fields or any other form of physical field as nothingness. This is a slight used by those in science communication, specifically pop-sci, I would argue, in an attempt to sort of, I would honestly say, obfuscate the notion of nothingness with respect to the creation of things as a means of attempting to combat particular theological implications that others might want to draw. So I genuinely think that's the reason a lot of people refer to these quantum fields as nothing, is because it's really just a slight against certain theistic implications or theological implications with respect to certain arguments about, creatio ex nihilo and creation out of nothing and the creation of the universe. So I think that's why it's done. This is not really nothing. Quantum fields are in a constant state of flux. There's particle-antiparticle pairs seething and frothing here and there in these fields. There's fleeting waves. There's a variety of activity that happens at this level of reality. To call it nothing, I think, is just a manifestly inappropriate way of communicating these concepts to the layperson. And again, I think it's done, quite frankly, to slight theism. To try to do, we can actually create things out of nothing. Well, no, but that's not really what's going on here. So that's sort of what the Schwinger effect is, that we can manipulate certain particles utilizing electric fields, and this will create other particles via energy to mass conversion. This is not creation out of nothing. This is not how quantum field theory works. And anybody with even a remotely basic understanding of quantum field theory, I don't think would concede that this is something that would be considered out of nothing. And again, I wanted to talk about this because I've actually seen a couple of atheists sharing this article around on Twitter, along with the one that I delete this one here by Ethan Siegel. And again, this is a much better article. If you're gonna read an article on this, read this one. This one is a pretty good one. This one actually explains the mechanism that was done, how it occurs, how this is a result of just, simple quantum field theory. This isn't, and Ethan even specifies, this is nothing in the physics sense, sort of an absence of matter, but not necessarily of other forms of energy or fields, just an absence of tangible matter. And if a physicist uses the term nothing, that would be more what they mean. Just like if you have an empty tabletop and you say there's nothing on the table, well, there are still probably bacteria sitting on the table, dust particles on the table. Maybe you were eating, soup on the table and there's some grains of salt still maybe sitting on the table somewhere. I mean, so we know that nobody means that there's a literal absence of literally anything at all on the table, because then that means you wouldn't even have the table. What we mean is that there isn't any visible matter that we can see sitting on the table. So yes, there are different contexts in which the concept of nothing can be used, but like I said, and I'm being honest when I say it, I do think that referring to quantum fields as nothing and referring to, spontaneous particle generation that's usually a result of energy to mass conversion as creation of matter out of nothing is manifestly inappropriate and inaccurate with respect to what these phenomena really are, and really helping people to understand what's going on. Because all this does is feed unnecessary fodder into the back and forth between theists and atheists and other, people who might not have a super strong understanding of physics about whether things can be created out of nothing. No, they can't, not in any meaningful sense of that term. If we want to take a very specified, I would often argue non-normative notion of nothingness, then I think we can. But yeah, so I just wanted to clear this up. The Schwinger effect doesn't say anything about creating matter out of nothing. That's not what it says. Anybody saying anything different is just making explicit their lack of understanding of basic quantum field theory. Not that I am a professional, because I emphasize on this channel all the time that I'm not, but I do understand these things more so than the average person does, such that I can better communicate to them what's going on than, say, somebody who's going to use either A, extraordinarily technical jargon and communicate nothing, or B, jargon that is so watered down that it no longer meaningfully communicates the concept. So no, scientists did not create matter from nothing in a groundbreaking experiment. It's groundbreaking in that it finally confirmed experimentally the Schwinger effect, something that we hadn't experimentally confirmed or observed before. That's what this did. It's not a creation out of nothing. So if you see anybody sharing this article or another one like it with you, where they're arguing, oh, well, scientists they've created matter out of nothing, so we can show that. And this person, I think, did they mention it in here? Yeah. There are many theories on how to create matter from nothing, especially as quantum physicists have tried to better understand the Big Bang and what could have caused it. This is sort of indicating what the slight is. The slight is against the theists. They're talking about, well, we can create matter out of nothing. Again, it's a slight against the theists who want to argue that you can't get something out of nothing, and therefore something had to have created the universe in the Big Bang. It couldn't just have spontaneously, arose out of nothing. The reason that people talk about this, the Schwinger effect, this experiment in this way, is, like I said, a slight against those theists who argue that in an attempt to try to dispel that argument. But this isn't really nothing. And to say that the universe came from some prior quantum mechanical state would not really be to say that the universe came from nothing, at least not in the sense that the theologians and the philosophers, and I would even argue many of the physicists, would probably end up saying. So I just wanted to clear this up. No, they didn't create matter out of nothing. If you want to use that definition of nothing, you're free to, but I just don't think it's really meaningful or helpful. I think at the end of the day, all it really does is kind of obfuscate the discussion here. It doesn't contribute anything meaningful. And so I just wanted to share some quick thoughts on this article and sort of dispel some of the, what I would argue, incorrect notions with respect to it, and again, outline things that I consider to be bad science communication. And until next time, remember, through reason we progress.